Hello friends. So today we are going to solve a vector calculus question. So let's read the question. If a vector equal to xy ax cap plus x square ay cap, then the closed line integration of a vector dot dl vector over the path shown in the figure is. So this is the path it is given. It is like a rectangular path. Okay, so we need to find out this integrations result. So before solve this, let's know about vector calculus. So vector calculus is the branch of, one second, the vector calculus is the branch of mathematics that deals with the differentiation and integration of vector fields. The reason it is so important in physics is that more or less everything in the universe can be described in terms of vector fields, electromagnetic fields, and gravitational fields and fluid flow. Now we can know some use of vector calculus so that we can get interest that why we are learning vector calculus. So first is classical mathematics, mostly fluid mechanics, their vector calculus is used. Also electrodynamics, we can't do anything without vector calculus. Subjects like general relativity and quantum mechanics also use things related to the simple vector calculus, tensor calculus, and vector space. In modern day computer programming and graphics, there also vector calculus are used. Point 5. Financial analysts use vector calculus in exotic derivative pricing. Point 6. To develop the Cockcroft-Gault equation, which determine the appropriate drug dose for patients with certain kidney disease based on the level of creatinine in their blood. Also in aerospace engineering and animator, this vector calculus is used heavily. Now some prerequisites are there that we can know. So let's change the color here. A three-dimensional radial position vector can be represented as L vector equal to x ax cap plus y ay cap plus z az cap. Means in the x direction it is what this length is x, in the y direction the length is y, in the z direction length is z. Okay, so you can learn like that. Means from in this point to this is the x value, and from this to from this to this is the y value. This is from this to this is the z value. Okay, so now Stokes theorem. What is Stokes theorem? We can we just need to know the formula here. So in Stokes theorem we can represent the closed line integral in the surface integral in the form of surface integral like this. So closed line integral of a vector dot dl vector equal to double integration del cross a vector ds vector. Also we can I think most of us we can know that any vector like a vector, this is the combination of the magnitude of a vector and the direction. So direction is like this. Okay, so this is the direction part. Means also we can like we can represent this as a cap like that. So this is the combination of the value and its direction. So similarly ds vector value is mod of ds and its direction is n cap. Now according to Green's theorem, we know, means we need to remember this formula: close integration of phi x comma y dx plus psi x comma y dy equal to double integration del psi by del x minus del phi by del y dx dy, and integration a to b dx equal to x, and the limit will be there, b upper limit b, lower limit a. Hope we know this. Also this formula, hope we know. You can see what is happening here. X's power is 1, so when we are integrating, so here we are adding 1 in the power, also in the below of this line we are writing 1 plus 1, so we are getting this half b square minus a square. So we need to solve this question. Let's copy this like this integration and this s value, so that we can relate our solution. So I am copying this a vector here. Okay, now we need to find out what we need to find out this close integration, so we can copy this also. Now the graph we are going to copy, so that we can relate the solution properly. So now by method 1 we can start the solution. So first of all, also we know that here we have learned the three-dimensional radial position vector can be written like this. Okay, we are copying this also. This is three-dimensional radial position vector. So TL vector will be dx ax cap dy ay cap plus dz az cap. Now we have seen that this is x y plane, so here z equal to 0, means there is no height in the z direction, so dz equal to also 0, that we can put here dx ax cap plus dy ay cap. Now we have in the question this a vector equal to xy ax cap xy ax cap plus x square ay cap. So we need to find out what? We need to find out this close integration. So here a vector dot dl vector equal to x y ax cap plus x square ay cap dot dl vector, that is dx ax cap plus dy ay cap. Now here we know that the dot product will be like ax cap dot ax cap, if like that it is there, so it will be 1. Okay, so here we can write xy dx plus x square dy. Okay, so now we can write the close integration again. A vector dot dl vector. This we need to find out. Okay, you can write here C also. Now, so this is a close integration throughout this closed line. So we can write it like this: PQ plus QR plus RS integration throughout this line and integration throughout SP. So first of all we can find out this PQ. So it will be like integration this we need to write here, but in this PQ line we can see this is constant. This is y and y's value is 1. So dy equal to 0. So if dy equal to 0, then so we can write this also like that, PQ. Okay, also better we can write P2Q. So dy, if dy is 0, so here we can copy this also to relate properly. Copy, paste. Okay, okay. Now here a vector dot dl vector, we have written this, but we found that throughout this PQ line dy equal to 0. So dy equal to 0, this part we can neglect, and here in place of y we can write 1. So it will be x dx and integration will be throughout the x, that is P2Q. X is varying from this 1 by root 3 to 2 by root 3. 1 by root 3 to 2 by root 3. So it will be x square by 2, 2 by root 3, upper limit, lower limit will be 1 by root 3, half, it will be like this. Hope you can understand. So here we are finding like that. Okay, so throughout this PQ line we are getting the value this. Now let's solve the integration throughout the QR line. Okay, so again what we can do, we can copy this graph to relate it properly. Copy, paste. Okay, so hope it is fine. Now it is fine, I think. Okay, now throughout this QR line we can write integration q to r this a vector dot dl vector. Okay, like we have written here also. Now in this line we can see here x equal to 2 by 3. In this line we can see x equal to 2 by 3. So dx equal to 0. and also a vector dot dl vector we can see from here. This is the value. Okay, copy paste so that we can relate a vector dot dl vector. This we calculated earlier. Sorry, here one thing is going out of the picture, so let's write this. Now here we are putting dx value 0 and x value 2 by 3. So this term we can neglect and we can use only this term. Okay, so here x we are putting 2 by 3 square, and dy integration will be from 1 to 3. 1 to 3. So it will be 1 second. Are we doing any mistake? Just cross checking. Okay, here 2 by root 3 is there, so it will be 4 by 3 into y 3 to 1, 4 by 3 into 2, 3 minus 1. So it will be 4 by 3 into 2, it will be 8 by 3. Now we need to find out throughout this line the integration value. So it will be IRS. Okay, IRS. Now let's copy this whole thing again. So that we can relate. So we can write similarly R2S a vector the dl vector. So throughout this R2S we can see this y value is remain constant. So here we can write y equal to 3 in this line. So dy equal to 0. So again we have written here, again here also it is cutting, so dy will be 0, so this term we can neglect, we can only use this term. So here we can put y's value as 3. Okay, y's value we are putting 3, so it will be 3 integration from R to S, so it will be 2 by root 3 to 1 by root 3. Okay, so 2 by root 3 to 1 by root 3, and here we will write this dx and x is there. X is there, y's value we are putting here 3. Now we can calculate x square by 2, 1 by root 3, 2 by root 3. Okay, so 3 into 1 by 2 into 1 by 3 minus 4 by 3. So here it will be 3 into 1 by 2 into minus 3 by 3. So it is cutting minus 3 by 2. Okay, so in this line also we got the value, integration value. Now in the line P2S a vector dot dl vector, this value we need to find out. Okay, so here again we can see in S2P what is constant. Here from S2P x equal to 1 by root 3. So dx equal to 0. So again we can put dx and x's value here. So we will get like 1 by 3 dy integration from 3 to 1. 1 by 3 into 1, this will be y, and the limit will be 1 to 3. 1 by 3 into 1 minus 3, so it will be minus 2 by 3. Now we got all the integration line by line, so the total closed integration will be the summation of all this line integration. So it will be pq plus qr plus rs plus sp. Okay, so I am copying this again so that you can relate. Okay, so we can write first integration throughout the line PQ. So what we got here. Okay, so we got half. So let's copy and paste here. Then QR we got 8 by 3. So we can paste here. Okay, now throughout the line RS, here we got minus 3 by 2. Paste it. Now throughout the line SP, copy, paste. Here it will be the plus sign. Now let's calculate what is coming here. 6 will be in the denominator. Now what is coming here? 3 plus 16 minus 9 minus 4. So it will be 7, 3, 10 minus 4, 6 by 6 equal to 1. Now this is the first method. Now we will solve the question with method 2. Okay, method 2. Now we will solve the question through Stokes theorem. So we can write our A vector again. It was this, we calculate. If you don't remember, I am showing you. Here we calculated A vector. Okay, here we calculated the A vector equal to xy ax cap plus x squared ay cap. That only we have written here. Now from Stokes theorem we know that close integration C A vector dot dl vector equal to double integration del cross A vector ds vector. This we have written earlier. before solving the question, you can see also here. So close integration a vector dot dl vector equal to double integration del cross a vector ds vector. This also we can represent like that. So we are copying this part. Okay, let's see we can place in the proper place or not. No, here it's not possible, it seems. Okay, yes. So here we are seeing there's close integration a vector dot dl vector equal to double integration del cross a vector, and this ds vector can be written the mod of ds vector dot n cap, the directional vector. Okay, now del cross a vector, del cross a vector will be, we can calculate like this: a vector ay cap az cap del x del by del y del by del z xy x square 0. So here we are writing the a vector values, and here the del is del by del x del by del y del by del z. Okay, a vector is xy ax cap plus x square ay cap. So we are writing in here the x is coefficient xy, we are writing here. Ay cap's coefficient x square is, we are writing here. As there is no az cap coefficient here, that's why we are writing here 0. Okay, so if we calculate this, we will find this az cap into 2x minus x equal to x az cap. Okay, so now again we can write like that: close integration dot dl vector equal to double integration del cross a vector ds vector n cap, ds vector mod n cap. So we calculated this part, so we can write here. So here other ax and ay terms are 0, that's why we written directly this. Hope you can understand this. Now we are proceeding here. So ds vector will be what, just assume, just 1 minute, assume, pausing my video. Now I am writing this dx dy. Dx dy we are writing because this plane is xy plane and z equal to 0, so that's why it's only xy plane, that's why we are writing dx dy. And as it is xy plane, so its direction will be in the z direction, so we can write n cap as az cap. Now integration, we can write the limit here: x 1 by root 3 to 2 by root 3, and y value will be 1 to 3. Okay, so here first we can write again y equal to 1, x equal to 1 by root 3 to 2 by root 3, 3 x dx dy. Now x square by 2, this 2 by root 3 by 1 by root 3, y equal to 1 to 3 dy. Now 1 by 2 here by 3 minus 1 by 3 Now y into 3 to 1, 1 by 2 into 3 by 3 into 2, 3 minus 1. So we are getting here 1. So I can see that method 2 is easier than method 1. So we can solve this question with method 2. Now another one method is there with the help of Green's theorem. So let's try to solve that. Method 3. So we earlier wrote this three-dimensional radial position vector, that is L vector equal to x cap plus y cap plus z cap. Again for we are writing this again. So for xy plane, so that I am writing it again so that you can if not get earlier, you can understand here properly. For xy plane, or if you forget that, you can remember. So for xy plane, we can write z equal to 0. So L vector we can write again x cap plus y cap. So del dl vector equal to dx x cap plus dy cap. Now a vector dot dl vector equal to x y. So a we can write again, so that a vector equal to that we have calculated earlier here. Okay, we can copy this, copy and paste. Okay, now I am again writing here xy x cap plus x squared y cap. So here we can see xy a vector dot dl vector. Now here a vector dot dl vector. So a vector is xy x cap, and here dl vector equal to dx x cap. So if we do the dot product, it will be only xy, and here x square dy. So now we can write what we need to calculate, that is a vector dot dl vector equal to xy, here also dx will come, sorry for that, xy dx plus x square dy, close integration. This one we need to find out. Now we can remember the Green's theorem. So here we have written this. We can copy this again so that we can relate. So according to Green's theorem, this close integration C phi xy dx plus psi xy dy equal to double integration this del psi by del x minus del phi by del y dx dy. So similarly we can means relate, like here psi xy is written, here this is written, and here phi xy is written, and here psi xy is written, here this is written. So we can make a arrow like that, and we can write from here 2 like double integration. Okay, so this is psi, so del x square by del x minus, and this is phi del xy by del y and whole dx dy. Now we can solve here. Also we can give the limit here, x equal to 1 by root 3 to 2 by root 3, y equal to 1 to 3, and here we can calculate 2x minus x dx dy. So we can calculate this similarly, but I shall not calculate this because we have already calculated this. You can see here. Okay, from this point the calculation will be same and it will come 1 only. So we solved the question with 3 methods, so we got the answer 1. So we can write